So in the meshing, for the meshing, all you need to do is give it a sizing. You can either give it for the body or you can give it for a surface, and you set the element size to what's given in the problem. So if I change the units to millimeters here, I've set, in this particular problem, I've set the element size to be 0.25 millimeters. And you can leave that behavior to soft because it may not be able to make every element edge equal to that, exactly that, but it'll do, mostly that. So that's what the mesh will look like. And then you have to, so that's all for the meshing. What about the physics setup? So it already knows that you want to solve the transient, governing equations for transient thermal conduction. And over here, the 2D behavior by default is Cartesian. So you have to change that to axisymmetric, and you can do that over here. So highlight geometry and change the 2D behavior to axisymmetric. And once you do that, you should interpret this distance, this coordinate as the distance from the axis, and this coordinate as the distance along the axis. And under surface body, you assign the right material, and this is how you specify the constants in the governing equations. Okay, so if I go back to my project page, and so if I look at engineering data, so I've using the same thing for two of my analyses. So if I go back here and look at that, I've defined this material cornelium, and it has the density, isotropic conductivity, and specific heat. So those are the three constants appearing in the governing equations. And to add these properties, for instance, you can go to physical properties, highlight density, and drag that to cornelium, and it'll add it over here. And in terms of the boundary conditions, okay, you have a convection boundary condition at the surface of the sphere, and that you can add by highlighting transient thermal and adding convection. And so that's H, the heat transfer coefficient. Film coefficient is industry terminology, and that's the ambient temperature. And then you have to add a zero heat flow at this boundary, and that's one way of imposing symmetry, because zero heat flow means that the gradient of the temperature perpendicular to that boundary is going to be zero, and that's essentially what symmetry is. And you don't need to give anything for this boundary because it is the axis. That's an assumption when you switch to the axisymmetric model. And since this is a transient problem, you also need to give an initial condition, which you do over here. And you can give it the initial temperature. And that's all there is. So boundary conditions, initial conditions, constants in the governing equations, axisymmetric form of the governing equations. And then under analysis settings, you can give it the end time until which you want it to do the time stepping. And you can turn auto time stepping off and give it a time step.